this. Okay, and we are recording. So, yeah, let me just share my screen and we'll just do it from scratch. Okay, coolio. But first, let's just quickly review the notes. So, do you kids understand what a container is and why we want to have what? Why we even care about like using them? Yay, nay? Okay, Joey gets it. Justine, like I will pick on you now because there are just two of you. Okay, right. So, essentially, let me bring up a picture then, because that's probably the most helpful. So a container is basically a computer running on your computer, right? So, like, have you played with like VMbox or something? Justine? So I will bring up the my this. Okay, cool. So you see how there is. Okay, this is probably not. Ah, yes, that's better. Docker containerization. So basically, you can run like operate a different operating system on your computer, right? So what you have is you have like your infrastructure, which is your actual like laptop or whatever, and then you have your host operating system, which is Linux or Windows or whatever. So this is what the operating system you're using right now. And on top of that, you install Docker, which is basically your container daemon. So this is going to control all of the containers, and inside, and this like basically handles all the containers and makes them run. So over here we have app A, app B, app C, and these are all containers. Now, what's inside this container? Each container is running its own little operating system. So this can be like Windows, this can be like Mac OS, and then we could have like Linux over here. I'm going to try to draw the penguin. Does that make sense, Justine? Yeah, all in one. It's all running on your computer, but so it's all still running on your computer, which I guess is Windows, or it's probably a Mac, right? But we're also running these operating systems on top of it. Okay, cool. And why might we want to do this? So you get what it is, but why should we even bother running like loads of operating systems on our computer? Any suggestions? Yeah, I mean, that's one thing. So different OSs have different advantages. Maybe you have like one part of so maybe you have like a big software application and one part of it runs on Windows and the other one runs on Linux. And you don't want to get two servers. So what you can do is you can set up two containers. One of them is a Windows server container and the other is a Linux server container. And you've now got them both running on the same machine, right? Another advantage of it is these are their own operating systems, which means they also have like their own file systems and they're all separated. So basically what happens is you can have so if you have like two pieces of software that use different versions of the same packages. So for example, one of them requires Python 2 and the other one requires Python 3. Instead of installing Python 2 and Python 3 on the same computer, and I'm sure that if you've done that, you notice how disgusting and painful that is, because what will happen is you'll accidentally run things in Python 2 and accidentally run things in Python 3. Having two different operating systems with two different versions of Python That's like a lot easier, or I guess not a lot easier, but a lot less confusing, right? Does that make sense? Okay, cool. So, let's just jump into this then. So what basically this entire module does is, or this entire like what today's tutorial is basically setting up one of these containers, creating a app that runs inside it, and then serving that app to the internet. So that's what we're going to do today. So let's just get right into it. I'm going to screen share now my terminal. Okay, is the text big enough for you guys? Okay, cool. I'm going to now type my password, which is I hope it's that. Okay, cool. And I'm going to get rid of my simple calculator because I want to go from scratch. Excuse me, what's going on? Done. Okay. So what I'm first going to do is I'm going to git clone. So I hope that both of you, I should say, managed to get past this step. So, oh no, I haven't changed my name to not Elena yet. Let me rename myself, not Elena. Done. Okay. So what we do is we git clone and then we do this. All good. Right, so you can see on this I've cloned the VM. Did everyone get this done at least? Justine, I'm looking at you. Okay, so I see the into simple calculator. Oop. And I've got this. So these are my files, and I can view them like this. All good. So basically, if I want to run it, then I can. Oh yeah, I first need to install my requirements. So it would be pip3 install, and then requirements, and that just installs all my stuff. And then I can run Python 3. So I first need to. Oh no, I need to export the port. So export the port equals 8080. Do you understand what this is doing when I type that? Okay, great. So I'm exporting the port, so that is a variable, and in fact I can you can see the port. So I've created a variable in the environment, and if I echo it, then it even says the port number. So I'm going to go echo. So wait, what do I need to do? Oh yes, I now need to run that app. So ls. So I've got app.py. So Python app.py. Okay, cool. And we now have the server that the server is now running. So this is getting it on localhost. However, we won't be able to see this because the localhost is so on this VM, you can only access it on the internet from port 80. And the issue is if we try to run it on port 80, so let's just do that, and I'll run I know it's Python 3 app.py. It says permission denied because port 80 is a very, very, very important port, and you can't do it unless you're like following all the security stuff, right? So it's generally not a good idea to do it on port 80 because if a hacker tries to hack you through port 80, then like you're a bit screwed, because port 80 is the port that everyone uses on the internet. Makes sense? So this is actually another like mild advantage of containers, being that if someone hacks the container, well, yeah, who cares? We could just restart the container. We can kill the container and restart it. We can delete the container even. It's all good. But if someone hacks like the underlying infrastructure, then you're a bit stuffed. Does that make sense, guys? So let's be smart and actually create the container. So this is now, I think, 5.4, 5.3, something, one of those two in the notes. And what we're going to do is we're going to create the container. So to create the container, all we really need to do is to create a Docker file. So I'm going to go into Vim and I don't know if I have Vim. Do I have Vim? Excellent, I do have Vim. So I'm going to go into Vim and I'm going to create Docker file. Excellent. And we'll go into insert mode. Okay, and now what we need to do basically is we need to create the Docker file. So let me just get the instructions so that I actually know what we're supposed to do. Okay, here it is. Okay, so the first, so we need to take the Python environment, then we need to copy the files, we need to install the requirements, and then we need to run the app. Okay, that's easy. So we first need to choose which operating system we want to use. So we're going to use a Linux distribution with Python pre-installed. So what we do is we just type from and then Python latest. So this is the latest Python distribution. Does everyone get this this line? So this is our starting point. We start with the Python stuff, and now we're going to start modifying it. So the first thing that we need to do to modify it is to say copy. We need to copy some stuff over. So let's try copy app.py, and we'll copy that to the current directory. We could do copy calculator, and we'll copy that to the calculator folder. And we need to copy the requirements, obviously. Requirements.txt to the current folder, file, and folder, and then we have to copy templates. And then we can copy that to templates. Right, all good. So does everyone get what this block does? It's basically just copying files from, so it copies files from our machine to the container. All good? Justine? All good? Okay, great. So now finally we're going to run. We need to run the installer. So we'll run pip install and then requirements. So there's the installation of the requirements done. Nice and easy. And then finally we need to start the app. So we do this with CMD. So this is the command that you run when you start the app. And you need to put it in this weird format. So we'll do command Python. So we'll run Python. And what arguments are we going to put in? We're going to put in app.py. Right. And then we can write this file. And we can quit the text editor. Do you get the last two lines, guys? So we install in the container, what we're going to do is we're going to install the requirements, and then we're going to run Python. Cool. So, as you can see now, we've got this Docker file over here. And what I'm going to do now is I'm going to ls and well, no, what do I need to do? Oh yeah, I need to docker build. So I'm going to build my Docker file and I'm going to give it a tag. So what's the tag? I'm going to call it calculator. And I'm going to build from this directory. So what does this mean? Docker build, that's the command. Now the T flag means that this is the tag that I assign it. So the tag is calculator. And where am I going to build it from? Well, I'm going to build it from the current directory. So now it's going to, you can see it's like, first it's downloading the Python thing, which is already downloaded. Then it's copying all of these, files. Then it's running the installation. And cool. So it's basically now it's packaged this entire like little operating system into something called an image. So we now have an image, like a snapshot of an operating system with all of these files installed, and that image is set to run this command as soon as you start it. And in fact, you can see Docker images. If you list the images, we now have an image called calculator. Right? And it says, actually, it was created 29 seconds ago. And since it is an entire operating system, though, that is 900 megabytes in size. Right? So now what we need to do is the final step. And let me find the step in the notes, which is this. It's 5.5, I think, or is it 5.34? It is in 5.4. So what you need to do is you just need to run docker run, and then this is going to be your port. So what port do you want to do? Well, I'm going to do port 8. So this is a port mapping. So I'm going to say I'm going to map our host port 80, and anything that comes into our host port 80 is going to be redirected to our container port 8080, right? And then the second thing that I need to do is I need to set the environment variable. So this is like export port equals 8080, and this export is happening within the container. Does that make sense? So does everyone get this? What this means? The colon notation and what this E notation means. Yeah, it's a port forward. So it literally says anything that comes, yeah, so redirect. So if something comes in on port 80 in the host, then we have port 8080. And yes, port 80 has to be open, but that's already enabled on your VMs. So what I'm going to do, and then I export port 8080 into the container. So the app is going to run on the container on port 8080. And then, but anything in port 8080 is mapped to the host port of 80, which means that anything that comes into port 80 on the host will be redirected to port 8080 in the container, and then the container is all good, basically. So the final thing is we just need to do calculator, which we could do like this. And I'm also going to add the detach flag. So I'm going to add a detach flag over here, which basically means that it will start it and then it will go into the background. And that's useful because I don't want to be stuck on it. So I'm going to run that. And oof, it says the port is already allocated, which means it's because I was playing with it before. So let's find something. It will be docker ps. This gives us a list. There's already something running on here. So let's kill it. Docker kill. because we don't want to wait for it to stop. And I'm going to kill it like that. And now Docker PS. Okay, cool. Now I can start the container like this, and it's all good. So in fact, I can see what's going on in here by typing Docker logs with this, with the beginning of the ID. 55B is just another container I was running. So you see that there's another container over here, and it's occupying port 80. And it's something that I set up earlier while I was playing around with it and just prepping, and I forgot to turn it off, so I just killed it. But if you look at this, we have Docker logs. If I run Docker logs, so this will view the logs from this container, so what's happening in this container, and you can see that it's running this Flask environment. So now, lo and behold, we should be able to access this from the internet. So we're going to have to use our public IP, which is the ones that are in your login details. But I'm going to now share my screen onto how about this? And I just type this in, and you can see that I now have a simple calculator app running on my machine, right? So now I can just type in things like 1, 2, 3, 4 plus 2, 3, 4, 5 times 2 or something, and it should return the answer. All good? So that's basically the web app. It has been deployed. Now, there are actually a couple of more other things that we can do, and I'll play around with that now just to show off how to do things. So the first thing is we've shown how to interact with your container by killing it and showing the logs. You can see all of the containers that exist right now that are running with Docker PS, by the way. But perhaps what might be even more useful is being able to access your container. So seeing what's going on inside your container. So let's Docker PS again to see what the name of the container is. And what you can do is you can do Docker exec, and this executes a command in your inside your container. So now what I'm going to do is I'm going to make it interactive, which basically means that it's not going to just execute and run away. No, the container will run anyway, I believe. So actually, let me think. Yeah, I think it will only stop if you kill it. I know that if it's the program that you start, if that dies, then the container will die as well. So you are right. But if Flask just goes into an error state, then there's a small chance, or there is a chance that the container will just continue running. So the best thing to do is to just try to kill it, or to stop the container. So essentially we can do this, and then we need to give the container ID, which is 115, and then I'm going to do bin bash. So this opens the terminal inside your container. So now you can see that I'm inside the container and I've got a terminal up, and you can see that I'm now root inside this container, and root is like the big boy. So let's see what's inside our container. So you can see that what has happened is that I've copied all of these files over as before, and they're actually stuck around the they're hanging around in the root directory along with all the system files. So if I go into cd home, there's nothing because there's no users here. I can see what's inside requirements, which is this, right? And I'm having lots of fun inside the container. And in fact, let's do a little bit of fun here. I can go into templates. Oops, where am I? Yes, CD templates. And I can modify the HTML file. Now note that this is not linked anymore to the HTML file outside the container on your host machine. This is now the HTML file inside your container. So it's separate. And if I go into this, oh no, they don't have that. Do they have Nano? No, they don't. Okay. Install. Let's install Nano then. Apt update. We're going to have to update our apt repository. Apt install Nano. Okay, cool. We now have Nano. We now have Nano. So let's Nano this. So you see how we have like this simple calculator, but what we can say is, for example, like let's say h2 hello. So this is just the we modify the HTML. We'll save it. Oh no, am I sharing the right screen? Wait, was I sharing my terminal? Guys, did I? Yeah, okay, thank goodness. Okay. And hopefully something should change. Maybe it hasn't because it's cached. Might have been cached. Let's try in a empty browser window. Oh, it's because it's cached. It's going to be cached by it's going to be cached by the actual container. Okay, never mind. That didn't work. That's sad. Is cached by Flask, I think. So Flask doesn't let you change it. Okay, that's disappointing. Never mind. I thought that would be fun. I might have to restart Flask then. Okay. And I won't bother doing that. Okay, so I'll exit. You can exit it by just typing exit. And basically that's how to interact with the your container. So I hope that you guys did follow along. Justine, have you been able to set up your own container now? Okay, do you think, you say not yet, but do you think that you will be able to in the future? Should be okay. Okay, excellent. So yeah, that's basically today's tutorial. And everything should be good. So tomorrow, or like with the rest of the notes, we're going to be looking at continuous integration and continuous deployment. So actually, let me just kill the recording now because it's something that we can do later. Recording, stop recording.